Welcome to today's video. This time around, we want to solve the question we have. The question reads, if f of x and g of x are differentiable functions, prove the formula for integration by parts. That is, the integral of f of x multiplying g prime of x dx to be equal to f of x times g of x minus the integral of g of x times f prime of x dx, and use that to solve the integral of w squared ln w dw ranging from 2 to 1. Now, to attempt this question, there are some few facts we have to remind ourselves of. Number one is that integration is also known as antiderivative. That is to say, integration is the reverse of differentiation. Now, to prove the integration by parts formula, which is quoted here, we need to use the differentiation by product differentiation. So what we do is to quote it in the form d dx of f of x and then g of x. That is two functions multiplying. If we have such an instance, what we do is that we find the derivative of one and multiply it with the infinitive form of the other, and add it to the infinitive form of the other and find the differential of the first one that we didn't differentiate. In simple terms, what we mean by this is this: f of x times g prime of x plus g of x times f prime of x. Remember that the two functions involved in the process are f of x and then g of x. Now, after establishing this first fact, note that we can attempt to go back to this original function by trying to integrate the right portion or the right side of the equation. If that's the case, we can therefore attempt that by bringing the integral sign and then integrating the right side of the equation, as we have in this case, to be equal to the original equation that we had. Now, remember that the sum rule of integration indicates that when two or more functions are separated by term, that is, be it minus or plus, in this case plus, we can integrate them separately. If that's the case, we therefore integrate this portion and then add the integral of the next portion, and that should still give us the right side of the equation as we have here. Now, if we continue with the process, remember at this point we can decide to make any of them the subject. But deciding to make the first part of the equation, the first term of the equation, the subject, means that we have to clear this second term in the equation. So we can have the integral of f of x times g prime of x to be equal to the right side, which is f of x times g of x minus the integral of g of x times f prime of x. Now, to make it more simpler, we can decide to let f of x be u and g of x be v. That being the case, we can rewrite this to be integral of u, because f of x is u, and then g prime of x. Remember, we have differentiated it, therefore we write dv because g of x is v, equal, these are the infinitive form or the original form. So f of x is u and then g of x is v, minus the integral of g of x, remember, is v, times the differential of f prime of x, or the differential of f of x, which is f prime of x, being du. Good. So the next thing we do is to attempt to solve the question. The integral of w squared ln w dw ranging from 2 to 1. At this point, what we do is to choose our u part of the equation. Now look at the setup that we have. The left side, says that we need a u portion and we need a dv portion. So we decide on which portion of this equation or this term or this function that we choose we want to be u. But in this case, I prefer to use ln w. Now there are some guidelines as to how to choose your u and your dv as indicated here, which I'll say, or I'll throw more light in subsequent videos. But for now, I would prefer to choose ln w to be u, and then w squared dw to be the dv. Now note that the right side of the setup requires us to get the v, also requires us to get du. Now we also need u, but u is already given as we have already chosen it. So what we need mostly is v and then du. So having u in place, we can derive du, that is by differentiating what we have here. So we say du over dw to be equal to 1 over w. Now in our previous video, we stated that a function of this form is differentiated to get this. So making du the subject, we end up with the dw over w, which is 1 over w times dw. Now at the right side, or at this end, we have dv to be w squared dw, right? Now to get v, we need to integrate both sides. Remember, this one is a differentiated form, or the differential of v. So to get the v, we need to integrate the v. So integrating both sides, we will be left with v to be equal to w cubed over 3. Good. The next thing we do is to input all of them into our original setup. So u giving us w, v giving us w cube over 3, and then u giving us ln w, minus the integral of v, which is w cube over 3, times du, which we had to be dw over w. Now note here that this will reduce the number of w we have here to be 2, while it will be appropriate to factorize the 1 over 3 that we have here outside. Doing that will cause us to have something like this, where we have w cubed over 3 times ln w minus 1 over 3 times w cube over 3. Now w cube is common, so we can factorize it out, and then we end up with this setup. Now note that we have not yet included our region of integration, so we have to input it and then include and then simplify. In doing that, realize that we just, wherever we see w, we input 2 there, and then take out or subtract wherever we see w, put in 1 there, and that is what we're doing here. So we put 2 there in this area, and at the end, or the next one, we subtracted the value of what we get by putting 1 in there. So following the process briefly, we will get to this answer, which is this form, which we can leave the answer like that, but you can also continue to simplify to get 1.07061. I hope that the video was helpful and at least you learned something new. Please continue to subscribe, click on the notification bell to get um, notified whenever there are new videos posted. Thank you for watching and bye for now.